This video is about compound inequalities, compound ands and compound ors. In this video, students will be able to understand and graph compound inequalities, and students will be able to solve and graph compound inequalities. What are compound inequalities? Well, let's make some connections. Okay, believe it or not, we experience these a lot. We just maybe don't think of them this way. So water is a liquid when its temperature is between 32 degrees and 212 degrees Fahrenheit. This, believe it or not, is a compound inequality. Water is a non-liquid, so either frozen or a gas, or a vapor, I guess, when it's below 32 degrees or above 212 degrees Fahrenheit. On the freeway, you must drive between 50 and 65 miles per hour. In certain restricted airspace, planes must fly below 10,000 feet or above 15,000 feet. And Disney World gives a discount to guests younger than 5 or older than 65. These are all examples of compound inequalities. Let's learn about compound inequalities. We have two types. We have ands and ors. Ands can look two ways. They can look with a variable in between two inequalities here, and literally with the word and in the middle. Ors can only look like this with an or in the middle. Okay, so we have two types. We have an and we have an or. You can think the ands of being both. So where separate graphs blank, and we would say overlap, it's where both must be shaded. It's where they cross each other. We'll see examples of this in a moment. And with an or, you go either way. So anywhere either of the separate graphs cover. Only one needs to be shaded. Let's look at some examples of graphing compound inequalities. Do notice that all three of these are compound ors. So we are going to graph them both, no matter what. Compound or graphs both, and looks at where they overlap. So let's start here and look at the numbers that we have. I have a 3 and a 7. Now you need to be careful because sometimes they won't be in a nice order for you. But if I think numerically, 3 comes before 7. So I want to put your 3's on the left and 7's on the right on all three of these number lines. And I'm going to graph them individually, then look at what they are together. So I'm going to graph x is less than 3. It'll be an open shaded to the left. X is greater than or equal to 7. I'm going to do a closed point on the 7, and I'm going to shade to the right. Now remember, it's a compound or, so you put them both down. This is a classic example of what most students think of when they think of an or. Ors can look all kinds of different ways, but this is kind of the classic we think about where it goes two different directions. Let's look at number 2. Again, double checking these numbers here. We have a -5 and we have a 6. Again, I go ahead and mark on my number line where -5 and 6 would be. -5 is the smaller number. Again, remember, the more negative a number, the smaller it actually is. So be mindful of that when we do some other questions. But now I'm going to graph them individually here in the middle and then together on the right. X is greater than -5, so I'm going to put an open and I'm going to shade to the right. And then we have x is greater than equal to 6. So I'm going to put a closed on this bottom number line here and shade to the right. Now again, this is an or, so you're just putting them both down. So really, all I need to do is graph that x is greater than -5 because it completely covers the x is greater than or equal to 6. If you want to put that on there, you can. So put a closed point there and shade to the right. But the one thing you need to be careful with this is if this had been an open point at the 6 here, so if this instead of greater than equal to, it was just a greater than, you do not then all of a sudden put an open spot on your graph. Again, when you're graphing this, you're putting both of them down. So if it happens to overlap the other one, you literally cover over top of it. Okay. Now, I tried to trick you. We have a 9 and a -1. So hopefully you don't just get caught in a habit of putting down the number on the left and the number on the right. So hopefully you put, whoops, that's a 9. I hope you put a -1 on the left and a 9 on the right. Again, it doesn't matter what order you graph them in the middle. It just make sure your numbers make sense. So again, negative numbers or smaller numbers on the left, bigger number on the right. So I'm going to put a closed point here to graph this. X is less than or equal to 9. And I'm going to shade to the left because that's less than or equal to. I'm now going to graph X is greater than -1. I'm going to put an open circle here and shade to the right. Now remember, this is an OR, compound OR. So what I care about here is putting them both down. And that means my entire number line is shaded because they cross over each other. Okay, now we're looking at some compound ands. A compound and can look one of two ways. It can either have the word and in the middle, like 5 and 6 do, or they can be written like number 4. Okay, again, this is a compound and. Now, when I'm doing this, I personally, to make it easier for me, split this and pull this apart. This is actually, and I'm going to use 2 different colors for this just to kind of clarify. It's the -4 is less than or equal to x. That's one of my inequalities. And then the other one, I guess I'll use red. X is less than, oh, that was not red. X is less than or equal to 1. Now again, this is a compound and. It's one of the 2 ways a compound and can look. So I'm going to write -4 is less than or equal to x. I'm going to write the word and in here. X is less than or equal to 1. Now for me personally, I do not like writing inequalities like this with the -4 is less than or equal with the variable on the right because I think it can get confusing. So I'm going to modify this even more. I'm going to write it up above it here. I'm going to flip it. So now it's going to be x is greater than or equal to -4, and it's a compound and x is less than or equal to 1. If you're able to, once you see enough examples of this, graph right from this first compound and inequality, if you can do that, be my guest. But for me, I'm always going to split them apart and write them like this because I think it's easier to understand what's happening. Same thing as with the ORs. I'm going to look at what number is bigger and smaller. Well, -4 is smaller, so I'm going to write -4 on the left. So a smaller number is the farther left you move. I'm going to write 1 on the right. And now I'm going to graph them in the middle individually, and then on the right, we're going to graph where they overlap. This is where it's different. Ors, you just put them both down. And a compound and, they want to know where they overlap. So I'm going to put a closed circle here because I'm going to go ahead and graph this x is greater than or equal to -4. So closed circle, shaded to the right. And then I'm going to do another closed circle on the bottom one because I'm graphing the x is less than or equal to 1. Now, when we think of an and, this is what most students will think of. They're going to overlap in the middle. In this case, it does. Ands can overlap anywhere, but when we think of an and, this is kind of the classic, it overlaps between the 2 numbers we're given. Now again, we could have a situation where it overlaps either side too, and we'll see examples of that. Let's look at number 5. So once again, be careful, okay? Not necessarily try, I know I said trick earlier, not necessarily trying to trick you, but it might feel that way, and you just need to make sure you're realizing smaller number goes on the left. So again, graphing the x, again, this is another compound and, graphing where the x is less than or equal to 0, so solid and shaded to the left. And then we have x is less than or equal to 8, so solid and shaded to the left. Now you got to be careful. If you're not paying attention if it's an and or an or, remember ands care about where they overlap. In this case, it overlaps at the 0 and to the left. Last one, number 6. Again, my two numbers. -7 is smaller. Again, keep thinking. Don't just get kind of robotically going through the motions and then write them in the wrong order, and it doesn't make any sense to you. Okay, smaller number on the left, smaller number is this -7. Okay, so I'm going to graph the x's greater than 4. So I'm going to put an open circle and shade to the right. Now I'm going to go ahead and graph x is less than -7 on the bottom one. So that's open and shade to the left. And when you look at this, this is one of the special cases. It doesn't overlap at all. Remember, when we were graphing solutions to this, when it was just a single inequality we were graphing, so we were solving it, we had a situation where we have a blank number line, and that's when it was no solution. Okay, it can happen in a compound and as well. Now, what if we were asked to reverse the process? So we were look at what we have, and we were to see if we can write the compound inequality out of what's there. So on here, I see that I have a -2 and a 4, and it's shaded in the middle. This tells me it's got to be an and. Okay, remember, ors are either going to go opposite directions or go one way or the other. This is overlapping the middle, so it's an and. So again, we would think, and I'm going to use x, this would be x is greater than or equal to, because it's closed, -2, and x is less than or equal to 4. That's the two inequalities that are there, because I'm shading to the left of the -2, so that's greater than or equal to, sorry, to the right. And I'm shading to the left, I got my left and right wrong, to the left of 4. So again, that's where you get the less than or equal to. On the second one, again, I see that it's shaded once again in the middle. In fact, they all are on here. Okay, so it's another and. This would be x is greater than 0. Notice how open circle, again, shading to the right. This other one shades to the left. This is a compound and because we're looking at where they overlap. This is going to be x is less than 8. On the bottom left, another and, kind of mentioned that already because where it's overlapping we know. This is x is greater than or equal to. It's shading to the right, so it's greater than or equal to -7. And we have it shading, it's open, so this is x is less than -5, shading to the left. This last one, it's another and. I have x is greater than -1. Again, noticing that it's open and shading to the right. And it's another compound and. You're going to be a closed point shading. It's going to be less than or equal to, shading to the left. So it's going to be less than or equal to 1. We could take any of these and write them as a compound and, how we saw our examples earlier. To do that, I'll just use this top right one as an example. So I have x is greater than 0 and I have x is less than 8. So what you can do with this is you're going to want to actually flip this left inequality. So it's going to now be 0 is less than x, and we have x is less than 8. And then you actually just put them together. 0 is less than x, which is less than 8. And you can write that as a compound and. So remember, as we go ahead and talk a little bit about some word problems with inequalities, I want you to remember our phrases that we've talked about in here. Again, some of my students struggled with the is at most and is at least, realizing that's less than equal to and greater than equal to. Okay, so just remember these. Let's look at some word problem inequalities. So on here for A, all real numbers that are greater than -2 and less than 6. So I would like to underline some of the important phrases here. We clearly see the word and here in the middle. So we're either going to write that as that compound and we talked about 2 slides ago, or with the word and in there. Let's let x represent our real numbers that we're talking about. I'm not very original, so I use x all the time. So x is greater than -2 and x is less than 6. For B, all real numbers that are less than 0 or, big clue there, greater than or equal to. Now, I do know that there's two ors here. You need to realize that this second or is kind of in our classic phrase for a greater than equal to symbol. Again, this is an or from where we see that in there. So we want values of x that are less than 0 or greater than or equal to, again, recognizing that this is greater than equal to 5. For C, again, all real numbers that are between. So when we hear that word between, again, think and, okay, that are between -5 and 7. So again, we want numbers that are between there. So x is greater than -5 and x is less than 7. Okay, and clearly it says between them. All right. One key word in this, I'll talk about in this next one. The circumference of a woman's basketball must be between. So we're talking about between here. We're thinking and between 28.5 inches and 29 inches. This word right here, inclusive, means you're going to be using a greater than equal to or less than equal to for this. If it didn't have the word inclusive, we would be using a greater than or less than. So again, I'm going to use circumference as x, not very original. You could use C if you wanted to, I suppose. So x is going to be greater than or equal to 28.5, compound and x is going to be less than or equal to 29 inches. Again, that inclusive is important. It means it's including those. So let's look at some more real life inequalities. When testing chlorine in a swimming pool, the pH level must be between 7.2 and 7.8. So again, things to notice here, it says between, so we should be thinking and as we're doing this, okay? We'll call the pH level X because I'm unoriginal. So X is greater than 7.2 and X is going to be less than 7.8. If I'm going to graph this, again, asking yourself what number is bigger. Well, 7.8 is bigger, so it'll go on the right. Now, again, notice the type of these type of inequalities. This is an and. If I'm going to be graphing greater than 7.2, that shades to the right. So I would have been shading this way. If I'm graphing less than 7.8, that's shading to the left. This is an and, so we care where they overlap. In this case, it's in the middle. This is kind of our classic and. My friend was stopping by to drop off a sweater she borrowed. I asked that she either arrive before 9 a.m. or after 5 p.m. Again, big clues here is this word or on what's going on here because I'd be out running errands. So I'm going to write the word or. This is an or. We have two different times here. We'll say the time that she's going to arrive, we'll call that X. So the time she's arriving at is X. So we're going to say X is either before 9 or after 5. Now, we have to be a little careful with this on our number line because I have a 9 and a 5. So I'm going to cheat and I'm going to use military time. So I'm going to say X. So if we're thinking time-wise, because we have 9 a.m. and 5 p.m. So to find military time, you just literally take any p.m. time, so any time in the afternoon, and you add 12 to it. So this would be 17. So I'm going to look at my number line here. I'm going to have my 9. I'm going to have my 17. Again, this is an or, so we're putting them both down no matter what. So open and shaded to the left is how I would graph this. This X is less than 9. And then again, don't use 5, use 17. That's military time. It's going to be open and shaded to the right for that. Again, when we see this, it's classic or going two different directions. Ors don't have to go this way, but this is kind of what we usually think of.